Materials, metals and non-metals. What is materials? The things around us which we can see it and occupy space. Material, a word, has come from matter. Now what is matter? Any substance that has mass and takes up space by having volume. So we'll just study now in detail about metals and non-metals. You must be familiar with number of materials like iron, aluminium, copper, etc. Some materials have been given below. So according to their appearance and hardness, you have to identify. Iron is, when we just discuss about iron, the appearance is shiny. And when we come to its hardness, it is very hard. When we talk about coal, or when we see coal, what is that? It is very dull in color and it is not very hard. The same with sulfur. It is also dull in color and also not very hard. Now when it comes to aluminium, appearance is shiny and it is very hard. When it comes to copper, again the appearance is shiny and it is hard. So now you can name the materials which are metals, okay. Now you can name it. The rest of the materials in 4.1 are non-metals. That means the substance which is very hard, they are metals and those are very light, okay, dull and not very hard. They are coming under non-metals on the basis of their physical and chemical properties. Now we will again in detail we will study about their more about metals and non-metals according to their physical and chemical properties. Now we will just recall the luster and the hardness are physical properties. Okay, according to that we will judge now, or we are going to see them. Now physical properties of metals and non-metals. Have you ever seen a blacksmith beating an iron piece or an article made up of iron, like a spade, shawl or an axe? So what is happening? What you will find? Do you find a change in the shape of this article on beating? Or would you accept that a similar change we try to beat a piece of coal? So we are just going to see now like how when a blacksmith with his hammer, when he beats the iron or with the coal, what is you are going to say? So with this small activity we will see the difference now. That is activity 4.1. First we will take a small iron nail, a coal piece, a piece of thick aluminum wire and a pencil lead. Beat the iron nail with a hammer. Take care that you don't hurt yourself in the process, okay. If you so when we are doing this thing we have to take care of ourselves. So try to hit hard, very hard, okay, the aluminum wire also. Then repeat the same kind of treatment on the coal piece and in the pencil lead. Record your observation in the given table. Now we will see the malleability of materials. Okay, malleability means changing of shape. So what is the object here? Iron nail. Okay, when you hit hard, okay, with the hammer, what is the change will become? Iron will become flattened, okay, it flattens its shape. What will happen with the coal piece? It breaks into pieces. Okay, when you hit hard with the hammer, what is the result? It is going to break into many pieces. When you hit hard with aluminum wire, what is happening? Again the change in shape become flattened, okay, it becomes again flattened. Now comes the pencil lead. Pencil lead also, if you beat with the hammer, what is happening? It also breaks into pieces. So you saw the shape of the iron nail and the aluminum wire changed on beating, okay. After beating it has become changed into flat shape. If they are beaten harder, this could be changed into sheets, okay. Again if they are going in under more chemical process and if you are beating again, you might be familiar with silver foil used for decorating sweets. Okay, so you remember the silver foil which you use it decorating sweets, or you must be also familiar with foil used for wrapping food. Okay, so this is one property, okay, this property of metals by which they can be beaten into thin sheets is called malleability. So we will say that metals are malleable, okay, and what we'll say, non-metals are non-malleable, okay, it cannot be changed into any shape. When we beat hard, what is happening, it breaks into pieces. So metals are malleable and non-metals are non-malleable. So this is a characteristic property of metals. So as you must notice, materials like coal and pencil lead do not show this property. So can we call these metals? Okay, we call these metals? No. Okay, they are coming under non-metals. Now comes the another property of metals, or another property of metal, that is, can you hold a metallic pan which is without a plastic or a wooden handle and not get hurt? Perhaps not. Why? Reason is that try list some experience in which a wooden or plastic handle protects you from being hurt while handling hot things. Okay, you have seen at your home also. Okay, when you are using a cooker, you can see that in the cooker it is aluminum and you are using plastic or wooden handle. So on the basis of this experience, what you can say about the conduction of heat by wood and plates, wood and plastic. So you can see wood is a, or plastic is a poor conductor of heat. Okay, it is having that resistance power. So okay, so your hand doesn't get burned. So you must have seen electrician using his screwdriver. What kind of handle does it have? It is also having most of the time plastic, and this you have studied in your previous topic. Now we will just recall this activity which we have done in the previous topic, that whether to test whether electricity can pass through an object or not. And you can see this, there is a battery over there, light is there, and you can see a wire over there and a nail. So if you keep on replacing with plastic or with wood, what is happening, when nail is there, the light will glow. That means it is a good conductor of electricity. So metal is a good conductor of electricity, and wood and plastic, when you replace with this thing, what is happening, the light will not glow. So that is a poor conductor of electricity. So now we will see here with this some experiments, we will see that whether these materials are good conductors or poor conductors. We can see that iron rod and nail, what is happening, when you keep this thing, it is a good conductor, you can see electricity passes through. When you keep sulfur or when you keep coal piece, what is happening, electricity will not pass through it, and what is happening, it is a poor conductor. And what is the copper wire, again it is a good conductor, it can pass electricity through it. So you observe that iron rod, nail and copper wire are good conductors, while the rolled sulfur pieces and coal pieces are poor conductors. So you understood now. So this changing, okay, this having that thing, okay, so here we can understand that metals are good conductors and non-metals are bad conductors of light and electricity. Now where do you find the use of aluminum and copper wires? Have you seen wires of coal? No. How? You have never seen wires of coal. You have seen wires of aluminum or copper. The property of metal by which it can be drawn into wires, okay, it can be done into wires, is called ductility. Okay. So this is the another property. What is the second property? That is, it is ductile. Okay, it can be converted or drawn into wires. So we can say that non-metals cannot be drawn into wires, so it is non-ductile. So here we have seen the second property of the metals. Now have you ever noticed the difference in sound on dropping an iron sheet, plate or metal coin and a piece of coal on the floor? If not, you can try it now. You can see, you can take one just a plate, steel plate, and you can take a wooden plate or anything or any other thing, piece of coal or something, and put it on the floor. You can understand that when you put a steel plate on the floor, it is having some bell ringing type of sound, and when you put a wood or you put some plastic also, you will not get any, you see any sound has been produced. So have you seen wooden bells in the temples? What is the reason? Because it cannot produce any sound. The things made up of metals produce a ringing sound when struck hard. Okay, when you struck anything with on the metals, what is happening? It is making a very hard noise. So suppose if you have two boxes similar in appearance, one made of wood and another of metal, can you tell which box is made of metal? By striking both the boxes. So this, the sound which is coming, okay, since metals produce ringing sound, they are said to be sonorous. Okay, what they are said to be? Sonorous. So the materials other than metals are not sonorous. Okay, so metals are sonorous. So we will see, we have seen the another quality of or another property of metal. After performing the above activities, we can say that some materials are hard. You have seen it, how metals are very hard. It is lustrous, it is very shiny, it is malleable. Okay, it can be beaten into different into shape. It is ductile, it can be drawn into wires. Okay, sonorous, it is again very it makes noise or ringing noise, so it is sonorous, and good conductors of heat and electricity. So the metals which generally possess these properties are called metals, and the examples of metals are iron, copper, aluminum, calcium, magnesium, etc. And in contrast, materials like coal and sulfur are soft and dull in appearance. They break into powdery mass on tapping with hammer, that we have seen in the experiment. They are not sonorous and are poor conductors of heat and electricity. So here you will get a distinguish between metals and non-metals. So these materials are called non-metals. So their examples, the metal examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. Now I will just give one small information about metals like sodium and potassium are soft. Okay, it is exceptional, we can say. It is very soft and you can cut it with knife. And mercury is also a metal which is found liquid in state at room temperature. Okay, this is the only metal you can find it room temperature, that is liquid state. Rest all you will find in solid state. These are exceptions. Okay, in the coming session, we will study about the chemical properties of metals and non-metals. Thank you, students.